This is a getting started guide to working with two-sided projects in the software. We're going to start by looking at a brief introduction to two-sided machining and then demonstrate the process of creating a two-sided project in the software. So what exactly is two-sided machining? This is where we use the same piece of material to cut one set of toolpaths on one side. We'll then flip the material over and cut another set of toolpaths on the other side, and then ultimately create a two-sided part. And so for this to work correctly, it is essential to have exact alignment between the top and bottom sides of the material. So how can we create a two-sided part in the software? Well, we have the ability to create double-sided projects in the same session. And depending on what software you are using, we can create and import vectors and components on either side of your part, where you can visualize the two sides in a multi-sided environment in both the 2D and 3D view, giving you the reassurance that everything is in the correct place. So how do we set our part up for two-sided machining? So when you first fire up the software and create a new file, you're going to want to choose to create a double-sided job. This will then put the software into a two-sided environment, where you'll then go on to specify your job size. Then you're going to set your Z0 position for both sides, where you could set the Z0 of the material surface for both sides, of the machine bed for both sides, or you could opt to choose to zero off the same face. Now there is no right or wrong way to set this, but I prefer to set the Z0 off the same side, where the top side is on the material surface and the bottom side is on the machine bed. This way it ensures that the Z is always referenced from the same face of your material. Now it's very important here to accurately measure the thickness of your material, and something that you may want to do if your material isn't particularly flat is to surface the top side so that you have a good reference face when you flip the part over. Then you'll go and set the XY0 position, and this will be the same for both sides. And finally, you will then choose the flip direction, and this is the way you will flip the material over on your machine to machine the other side. And this flip direction influences the positioning of the vectors and models if you're using VCarve or Aspire, so that the geometry on each side is created in the appropriate positions relative to the opposite side. So now that you have the part set up in the software, and depending on what software you are using, you can create or import vectors and components independently on either side of the material, with the ability to copy or move data to the other side too, where the software will position geometry in the appropriate positions relative to the opposite side. So you never really need to worry that your data is misaligned, as the software automatically positions and aligns data that you send to the other side for you. And using the multi-sided view, you can proof your data positions in both the 2D and the 3D view to help visualize your two-sided part. And then you could go on to calculate the appropriate toolpaths for both the top and bottom side, where you can preview the toolpaths in a multi-sided environment for accuracy. Then once you are satisfied with your preview, you can save out the toolpaths for both sides and then set up your part on your machine to run the top and bottom set of toolpaths. So how do we physically align the XY location of the material when we flip the part over? Now the method that we are going to talk about uses dowel holes to help us align the XY location when you turn the part over. So here you can see a picture of the top side of our part, and there is a hole that we have cut for the dowel. Here is the sacrifice sheet on our machine, and you can see that we've machined two dowel holes in there, inserted the dowels, and now when we flip the part over it should locate correctly on those two locations. Now there are two ways to approach this. And so one way of doing this When you're cutting the top side of your job, you'll want to machine all the way through the part and into the spoil board, and use the same XY0 position for both sets of toolpaths. If you're going to do that, you need to have a symmetrical hole pattern so that the positions are in the same location when you flip it over. You also need to make sure that when you are doing this, that you cut both the top and bottom sides in the same session of machining on your CNC. This method wouldn't allow you to stop the CNC and switch it off unless you could very accurately position the XY0 to the same location. And so to get around that, we have another option, and this is to drill dowel holes partially through the top side, and then in the software we would copy the dowel positions of the top side over to the bottom side, where we would then separately drill the holes for the bottom side directly into the spoil board, so they're not done as a single operation. And there's a couple of benefits to doing this. One is it allows us to use a non-symmetrical hole pattern, because we're going to be able to reverse that pattern and machine it into the spoil board when we flip the part over. And it's nice to use a non-symmetrical pattern because then we can ensure that when we flip our material over that we only have one way that we could possibly relocate it onto our machine surface. And so this eliminates the fact that we might flip the part in the wrong direction to what we set in the software. Now the other benefit is that I don't need to run the toolpaths concurrently maintaining the XY0 position between the top and the bottom, where I could cut the top side on one day with this drill pattern machined in the top side for the dowels. Then I can take the material off, I could run other jobs, I could turn the CNC off, and then I could come back to it at a later date, and when I finally come around to running the other side, then the first operation on that day would be to machine the dowel holes of the bottom side of the job into the spoil board. Then I know that I'm going to accurately locate what I machined first and then machine all of the other toolpaths for the bottom side, and I know that everything will line up correctly. Now the process that I've described here does require me to have a sacrifice sheet on the bed of my CNC in order for me to machine the dowel holes into. Now if your machine doesn't have a sacrifice sheet, then you can attach a temporary one by clamping a piece of MDF down. An alternate method to that you could also use is to create a corner jig and just ensure that you can pre-size your material very accurately, and you can set your XY0 to the corner of that jig very accurately too. So this method, when done correctly, will give you excellent alignment in X and Y. And so there are many strategies that you could use to approach two-sided machining on your CNC that you could explore, and I'm going to show you the symmetrical dowel method in the next example. Now the file that we're going to look at now to demonstrate a two-sided project in the software is based on one of the free monthly project files called Cool Cubes. And the file that I'm going to work with is an edited file which you will have access to in the project folder. So we're going to look at creating a version of one of these boxes, and these boxes are designed in a way that we cut the decorative elements on one side of the material and a series of pockets on the other side, and these pockets will enable us to assemble and join them together to create the box. So let's go into the software to set up our part. So to open up a file that I've edited, I can come over to open an existing file, and here I'm able to browse through my machine to search for the particular file that I'd like to reopen. So here I'm going to go and locate my two-sided machining getting started folder, and we're going to open coolcubes_edit and then press open. So here we're looking at the overall design for one of the Cool Cubes boxes, where we have a box that has four sides. So we've got two side panels, we've got a rear panel, a front panel, and then we've got a top piece. We're going to look at cutting the bottom piece separately, and that will be just a simple square shape. Now the vectors that I'm highlighting here will represent the decorative area of our box, which will be on the outside of our box, and then these rectangular vectors that you can see here represent areas that I'm going to pocket out in order for the box to join together, just as we saw in the slide earlier. You'll notice we also have these dowel hole locations, and then we've just got some text at the bottom just to tell us what each part actually represents. Now, the file that we have opened here was originally saved from a single-sided session. Now, as we are creating a two-sided part, I need to ensure that we create a two-sided environment. So let's go over to the file operations, and we're going to set the job dimensions and origin. When I click on that, that's going to open up the job setup form. So you can see we currently have single-sided job type selected here. So to select double-sided, we simply click on this radio button here, and you'll notice that I have additional options presented to me within this form that are applicable to the double-sided setup. So moving down the form, we now need to check over the job size, ensuring that it's appropriate for the material that I plan to cut. Now, I have 1/2 inch thick material, and it can accommodate the width and height that we've got set here, plus extra room for any hold down methods that I'm going to use to hold my material down. Moving down, we're going to look at the Z0 position. And this is where we set the Z0 position for both sides of the material, where 1 represents the top of your material and the number 2 represents the bottom of your material. The graphic on the left represents the top, so this is where we indicate where we want to set the Z0 position for the top. The graphic on the right represents where we want to indicate our Z0 position for the bottom side of our material. At the moment, we can currently see that the Z0 position is set on the material surface for both sides, because this is highlighted here, and I have a red indicator in both graphics telling me that for the top side we're setting it to the material surface, for the bottom side we're also setting that to the material surface. I can switch and change that to the machine bed by selecting the machine bed option, and you'll notice that the red indicators have moved to the bottom of the block, which is the equivalent of the machine bed. So for the top side, the Z0 is now at the bottom of the block or the machine bed, and for the bottom side, the Z0 is also at the bottom of the block or the machine bed. We also have the option to set our Z0 off the same side, and that way we'll always be able to reference from the same face of your material. So to do that, we simply check that option there. You'll notice that the indicator has changed for the bottom side. So let's have a look at the setup now. So for the top side, we've got Z0 set to the machine bed. And then when we come to flip the material over and work on the bottom side, we're going to set the Z0 from the material surface. So we're referencing from the same face. Now, I prefer to set the Z0 off the same side, but where the top side of the material is on the material surface. So we're going to look at setting Z0 for the top on the material surface here, and when we turn the material over to cut the bottom side, we're going to set Z0 off the machine bed or the bottom of the block, just to ensure that the Z is always referenced from the same face of the material. Then we need to choose our XY datum position. So I'm going to leave that in the lower left hand corner. I can see it's indicated in the graphic there by this red dot. Not only that, I can actually see that in my job space. I can see it's in the lower left hand corner of the white space, and this white space represents my job area. And the XY0 position will be in the lower left for both sides. Then we need to choose the direction that we flip our material over. Now, it doesn't matter which one you choose, you just need to remember how to replicate this virtual flip when we come to physically flip the material over on our machine. So we have the option to flip this along the x-axis, we could flip that along the y-axis. In this case, we're going to go with this option here, and then we could go and simply press OK. So you'll notice that we now have additional icons at the top of my user interface, which are all relative to the two-sided setup. And we're going to talk about what each one of these represents. I'm just going to click on this one just to disable that, and we're going to come back to this and talk about what this does shortly. So let's come over to this area here. Now this icon here represents the direction that I chose to flip my material in the job setup form, where we chose to do that along the x-axis. And being able to see this at the top throughout my session will remind me which way I chose to flip my material. So it's useful having that indication there as a reminder. Now I can't click on this, but if I did want to change the flip direction so we're now flipping in the y-axis, I can do that by going back into my job setup form, where I'd select this option here, and I could go ahead and press OK, and you'll notice that the icon has changed and it's telling us that we're now flipping in the y-axis. Now I want to flip that along X, so I'm going to go back into the job setup form and change that back so it's doing that in this direction. I could go ahead and press OK, and so it's just useful to be able to see which way we're flipping our material all throughout my session. Then we have this button here, and this indicates which side I am currently viewing. Now the arrow is pointing to the top of the block, therefore I know that I am currently looking and working with the top side of my material. To switch to the bottom side, I can click on that, and you'll see now that the arrow is pointing to the underside or the bottom side of the material block in that graphic there, and so it's the software's way of telling me that I am now looking and working with the bottom side. You may have also noticed that my rules have changed colour, and so we've got these orange shaded rules here, and this is just another indication to remind me that I am now working and viewing the bottom side. Now not only can I switch sides using this button here, but I could also look at using the shortcut keys on the keyboard, where the number 1 takes me to the top side and number 2 takes me to the bottom side. So let's just switch back to the top side by pressing 1 on the keyboard. Now at the moment all of the vectors are currently on the top side. I also have an additional icon over here in the view toolbar, and that enables me to work in a multi-sided view. Now this will enable me to see vectors that I may have on the other side in the 2D view. It also enables me to see 3D information in the 3D view. For example, when I simulate toolpaths for both the top and the bottom side, I'm able to look at both sides in the 3D view. So let's turn that on and see what happens. So we'll just click on that icon. You'll notice that the icon has changed. It's got an additional bottom side here, and it's currently highlighted. So I can see that multi-sided view is currently switched on. Another way to access multi-sided view is by pressing the equals key on the keyboard. So if I press equals now, that's going to turn multi-sided view off. If I press equals key again, it's going to switch that on. Now you've probably noticed there hasn't been much of a change here in what we can see in our part, and that's because we don't currently have any data on the bottom side. So if we now switch over to the bottom side, and so you can now see that with the multi-view switched on, I can view the vectors on the other side as though I was looking through the material. Now these vectors that I can see on the other side are a light green. I can't select them or edit them on this side, I can just see them. And so we can see now that the text is reversed and the top panel is now on the left hand side because we're flipping the part in the x-axis. And so this is very useful, having the ability to see the opposite side's data in terms of where I create new vectors relative to the vectors on the other side. And a very handy feature here is that I'm able to snap to geometry that exists on the other side too. For example, if I go into the Draw Rectangle option, I can snap to points that are actually on geometry on the other side. So you could see that again. I can snap to this point here, click and drag to create the new shape like you can see there. And so if I switch multi-view off by clicking on that icon, you can see that I can no longer see the vectors that are on the top side of my material. So let's just take this vector here, shift and select this vector here. I don't actually need these, so I'm just going to use the delete key to delete those. I'm going to go back to the top side, so I'm going to use the top side here, and I'm also going to switch on the multi-sided view here, as having that switched on is very useful for me to see all of the information within one session. Now I don't need to create any vectors in this example. I have all of the vectors that I need here to create my box. I just need to organize them into their sides. So I'm going to select all of the vectors that represent the outside of my box. That's all of the circles, the decorative area, and the actual cutouts for each one of these panels. So to select multiple vectors, I can simply click, and if I drag up over to the left hand side, you'll see I've got a selection box there, and any vector that touches this selection box will be selected. So I have all of the vectors I want here for side panel, and then I'm going to hold down shift, and that will enable me to select another set of vectors, and again click and drag up to the left hand side, and those are selected. We'll do the same for the other panels over here, and then for the top on the right hand side there. Now with those vectors selected, we need to move them over to the bottom side of our material. So to do that, I simply right click, use this option here to move to the other side, and when I click that, the software will move them over to the bottom side. And you can see that with the multi-view switched on, I can see that the software has accurately aligned the vectors over to the other side based on my X flip direction. And again, having the multi-sided view switched on is extremely useful for us to be able to better visualize the overall part in a two-sided environment. And so if we go and switch over to the other side, we can see that those vectors have been moved. Now one thing I want to point out here is that we are using symmetrical dowel holes, so that when I flip between each side, the dowel positions appear not to move, and because they are symmetrical, when we flip the material over, we are guaranteed to have the correct alignment in X and Y, where X0, Y0 is in the lower left for both sides. So now I want to run through how I plan to cut the whole part. Now in terms of machining, I plan to cut these vectors using the pocket toolpath so that we can assemble all of the panels to form the box. Then I'm going to take these vectors here, and we're going to machine the dowel holes all the way through the material and into the spoil board. And that is all of the toolpaths that are required for the top side. So we'll then take the material off of the machine bed, and we'll insert the dowels into the holes in our spoil board, where we'll then flip our material over along the x-axis, and then we'll look at positioning the material for the bottom side on the dowels to align at X0, Y0, in which case we'd then secure the material in place, and then we're ready to machine the toolpath for the bottom side, where we're going to look at creating profile toolpaths on all of these holes to form some decoration, and then we'll finally run another profile toolpath where we're going to cut each one of these panels out. So let's switch back to the top side. So now that we've got all of our vectors on the correct sides, we can now go and create our toolpaths. Using this icon here, we're just going to undraw the Design tab on the left, and that's going to open up the Toolpaths tab on the right hand side. And here I have access to the various icons where I can create and edit toolpaths. So you'll notice not only can we tell that we're on the top side because of this icon, but over in the Toolpaths tab it's currently telling me we are working with the top side. So that's just a good indication there of what side we're currently working with. Now, as with any setup here, we should always go and check over our material setup before we go and create any toolpaths. So we're going to use the Set option here. Just going to check over the settings here. So material thickness is 1/2 inch. XY position, as we've said, is going to be in the lower left hand corner. The Z0 position, so you can see we're currently looking at the top side where we chose to set the Z0 off the material surface here. Rapid Z gaps above the material, so you want to check that the clearance and the plunge are safe and appropriate for what we're doing. And we've got our home start position at X0, Y0 with a Z gap above the material of 1.5. So everything seems pretty reasonable here, so I could go ahead and press OK. We're going to use the pocket toolpath to create our first set of vectors. So we're going to select this vector here, shift and select this vector, and this vector. And with those vectors selected, we can come over to toolpath operations where we'd select to choose the pocket toolpath option. And so this will open up the pocket toolpath form where we can edit the settings in here according to what it is we want to do. So the start depth for this is going to be at 0 on top of the material surface. Cut depth in this case, we're going to cut down 1/8 of an inch, so I'm just going to type that value in there. The tool we're going to use is a 1/4 inch end mill. I can see that the 1/4 inch end mill is currently selected here, so I could use the edit option just to check over the settings, ensuring they're safe and appropriate for the material that I'm cutting. I'm happy with that, so I could go ahead and press OK. And so moving down the form, to clear the pocket, I'm going to do that in a raster strategy where the raster angle is at 0, so it's going to cut parallel to the x-axis. I can go and give this a name, so I could call this one horizontal pockets, like so, and then I could simply go and press calculate. So here you can see that I'm displayed the toolpath there, and I could go and preview that information and take a look at the parts that we've got here. So let's just put that in Z. I'm happy with what we've got there, so I could just simply close out and we'll switch back over to the 2D view. Now I'm going to select all of the vectors that represent the vertical pockets. So I'm just going to click and drag up in the upper left direction, and anything that touches my selection will be selected, so I can see I have all of the vectors that I need here to create my next toolpath. So with those selected, let's go back over into the pocket toolpath. So again, we want to go over our cutting depths. The start depth here is going to be at 0, the material surface. Cut depth, I want to cut a little deeper this time, so we're going to change the value there to 1/4 of an inch. We're going to use the same 1/4 inch end mill here, where we're going to clear the pocket in a raster strategy. This time we're going to put in a raster angle of 90 degrees so that it cuts parallel to the y-axis. Then we could come down and give this a name, so this time we're going to call this one vertical pockets, and I could simply go ahead and press calculate. You can see the toolpath displayed there in the 3D view. It's automatically opened up my preview toolpaths form, where I now have the option to actually preview that and see how this will look if we was to actually machine this on my CNC. Okay, so I like what I've got there. You can see that we are cutting a little deeper than our previous cut, and that's going to help when we come to assemble all of the panels together to actually create that box. So we'll put that in Z, and then we'll just close out of the preview toolpaths form. So again, let's just switch over to the 2D view. So I'm just going to click on that tab there. And now we're going to look at running the last toolpath for the top side, and that's a drilling toolpath to cut our dowel holes out. So that vector selected, I'm going to hold down Shift to select this vector, and I'm going to come over into our drilling toolpath. So we need to specify our cutting depth. So the start depth again is at 0, the material surface. Cut depth, so I want to cut all the way through our material, which is 1/2 inch, and I want to cut a further 1/2 inch into my spoil board. So we're going to have a total cut depth of 1 inch there. The tool we're going to use, if I use the select option here, I'm going to go to my drill section, and I can see that I have a 1/4 inch drill in there. I can check the settings, ensuring they're safe and appropriate, and then I could go ahead and press OK. I could give this a name, so we're just going to call this one dowel holes, and then I could just simply calculate that. Now a warning message will come up telling me that we are cutting all the way through the material. That's okay. I intend to do that to ensure that my dowel holes can go into the spoil board so that I can align the bottom side of my material when we come to flip that over. So I'm going to go and press OK here. You can see the toolpath displayed, and if we preview that, you can see the hole has been positioned on either side of my material there. Okay, so I'm happy with what we have there. So at this stage, what we'd do is we'd then take our material off of the material bed, and then we'll insert the dowel holes into the spoil board, and then we're going to take our material and we're just going to flip that over along the x-axis like this. We'd align it to the dowels and secure it in place, and that way we know that our x, y, 0 coordinates are going to be aligned with each other. And then we'll just look at running the other toolpaths. So let's just close that preview down, and now we're ready to switch over to the bottom side. So I'm going to click here. So here we can see that we're now on the bottom side, and if I just switch back to look at this down the z-axis, it's going to correct the 3D view there for me. So we're now looking at the bottom side of the material. And so for good measure, let's go over to the set option to open up the material setup form. So material thickness is 1/2 inch, that's correct. XY datum position is in the lower left hand corner, that is also correct. Then we move on to our Z0. We can see we're currently looking at the bottom side here. So again, it's indicating that we are looking at the bottom side, and we're setting the Z0 for this side. It's already been set. We set that right at the start of the job, so we needn't worry about this area, but it's good for us to just check and glance over the settings just to ensure that they are correct. So here we've got it set to the machine bed. Now, as I said earlier, I do prefer to set the Z0 off the same side, where the top side was on the material surface, and now that we've flipped the part over, the bottom side is going to be on the machine bed. This way it ensures that the Z is always referenced from the same face of your material. And again, check over the rapid Z gaps above the material, home and start position, the Z gap above the material. So from the top of the surface of the material, we're going to have a Z gap above of 1.5. So we could go ahead and press OK. So you can see that I have the warning. Again, it's about the dowel holes. I'm happy to go through the entire thickness of my material as I intended to. So I'm just going to go and press OK there. So now we're going to look at creating the decorative elements of our box. So let's switch over to the 2D view, and I'm just going to select all of the vectors here. Again, just dragging up to the upper left hand corner, just so I'm touching the vectors that I want to select. And with those selected, let's come over. We're going to look at the profile toolpath. So here we're going to specify a cut depth of 1/8 of an inch. So I'm just going to type that value in there. Then we need to select a tool from the tool database. In this case, I'm going to look at using the 1/4 inch ball nose tool. I could go ahead and OK that. Machine vectors, I'd like to machine on the inside of each one of these circles. So we're going to use the inside option here. And come down to the bottom of our form, and I'm just going to give this a name. So I'm just going to call this one Decorative Holes. And then we could just go ahead and calculate that, so I can see the actual path that's going to take, and then I could just simply preview that toolpath and we can see how the part looks. And so I like what we've got there. We've got some nice decorative elements to the side panels of our box. So let's just put that down the z-axis. We're going to close out of the preview toolpaths form. Go back over to the 2D view. We're going to look at running our last toolpath. That's a profile toolpath to cut each one of these panels out of our block of material. So to select them, I'm just going to drag a box to select all of those, and then we're going to come over to the profile toolpath form. So here we're going to specify a cut depth of the material thickness. So in this case I could type in Z followed by the equals key, and that will input the value that I've entered for our material thickness, which is 1/2 inch. I'm going to select a tool, so I'm going to use the select option here. I'm going to go back to the 1/4 inch end mill. I could go and press OK. I'm going to machine these vectors on the outside of those vectors to cut our panels out. If we come down the form, I'm just going to use this option here to add tabs to the toolpath. So I'm going to check that option there, and you'll see that it's remembered the tabs that were originally in place from the original file. Now I'm happy with the position of these tabs. If I wanted to edit them, I could use the edit tabs option, or I could insert new tabs or remove or move the tabs around to a position that I liked. I can alter the length and the thickness. Now I'm happy with the length that we've got there, and I'm also happy with the thickness of the tab. It seems quite appropriate for the material thickness that we're working with. Come down to the bottom here, we're just going to give this a name, so we're going to call this one Profile Cutout. I could simply go ahead and press calculate, and then I could just simply preview that toolpath. And so looking at this preview, I'm able to twiddle that around just to get a good look at what our part would look like here. Because we have multi-sided view switched on, I could just simply spin that around where I can still look at the bottom side to ensure that I have correct alignment, everything looks correct per top and bottom side basis. And it's very important that your part looks correct at this stage, as the toolpath preview shows you a very accurate representation of what we should see on our CNC machine if we was to go ahead and run these toolpaths. So if something doesn't look as you wanted it to here at this stage, then you can go back and make edits to the toolpaths, recalculate them until you are satisfied with the results that you can see here in the toolpath preview. And that's what makes the toolpath preview such a powerful tool. So now that I'm confident with the toolpath preview for both sides, we could go to look at saving out the toolpath. So to do that, let's just close out there, and I'm going to go and switch over to the top side here, and then we're going to look at using this option to save the toolpath. So let's use the save option here. Okay, so you can see we currently have the horizontal pockets highlighted here. Now I know that these pockets are both using the same tool, so what I could do is select horizontal pockets along with the vertical pockets and use this option here to output all of the visible toolpaths to one file, so I can see that they are now both listed here. I can also use this option here to add side to the toolpath name, and so when I check that option, and then I come to choose the appropriate post processor from the list, and so in which case I'm just going to go with this generic G code here. When I come to save the toolpath, you'll see it automatically puts top in front of the toolpath name, and I can change that if I wanted to, so I could just call this one top and pockets, and then I could just save that out and then just deselect these and select the Dowel holes toolpath here, where I could just simply go and save that toolpath out, and again it will put top at the front there, so I know when I come to select my toolpaths that all the toolpaths for the top side have the word top in front of it. So we'll just save that out also. So let's just close out there, and we're just going to switch over to the bottom side, and then again we'll go back into the save toolpath where we could just simply select the decorative holes, and we can see the toolpath is listed here. We can check to add side to the toolpath name, choose the appropriate post processor from the list, save out that toolpath, and you'll see now it's displayed as bottom with decorative holes in there, and then I could go and save that out and then select the profile cutout, and again save that out, and it will call that one bottom profile cutout, and I can save it, and with those toolpaths saved I can then go and take them over to my CNC machine to cut them out. Now that I'm ready to go and run my toolpaths, I'm going to make use of one final feature in the software, and that's to create a job sheet, and this will detail all of the important setup information for my part that I can take with me to my machine to ensure that I set up my part correctly. So we're going to look at creating a job sheet for the bottom side. You can see we've got a name in there. The software just defaults the name from the name of your actual file, so I'm just going to go with that, and then we'll go ahead and press save. And then if I go to the top side, we're going to do the same for the top side, so we'll create a job sheet here, and you'll see it displays the same name. Now you'll notice in the folder that we've saved the previous sheet to, it's automatically included bottom at the end of the name, so we know that we're working with the bottom side. So here when I save this out as the default name, I can save it, and then when I come to open up that folder, I can see in my folder here I have underscore top and an underscore bottom here. So then what I can do is I can double click on the HTML link, and that's going to open up my job setup sheet, and this will display the layout here in the top. You can see that I'm working with a double-sided job, which side of the material we're currently working on, the flip direction for the part, the dimensions, home start position, the Z0 position on top of the material for the top side, XY in the lower left, the clearance settings, and you can see the various toolpaths that we've got listed here. And then if I just exit out of them, we'll look at the bottom. Again, you'll see it will display the vectors for the bottom side, tell us again we're working on the bottom side, and we can see that indicated by this icon here. You see that the Z0 is on the bottom this time, and I'm displayed the two sets of toolpaths here. So it's all important information that I can find very useful when we come to set up my part on my CNC. So let's just exit out there. We're just going to close this folder down. So that completes this getting started tutorial for two-sided machining. So let's go and save the file. So go to File, Save As, and in the project folder we're going to call this one Two-Sided Machining Getting Started. Press Save, and you can access that from the project folder.